Welcome back to the Daily Dean. This is my quick rundown of scientific things that sound really complicated, but aren't, explained briefly. We'll be talking about quantum mechanics, neutron stars, quasars, pulsars, nuclear power plants, and dark matter. You'll notice that a lot of those are space, because astronomy is really cool. Now, quantum mechanics. Quantum mechanics does not mean super physics or super, intense physics 2, electric boogaloo. That's not, it just means quantum physics. Quantum referring to really, really small things, the smallest things possible. Anything related to atoms and smaller than that. So when we refer to quantum mechanics, we're thinking about how, atoms interact with each other, what are the characteristics of atoms, what make up atoms, etc., etc. And you may have heard in Ant-Man, the quantum realm. Quantum being, the smallest possible place you could be. That's basically, a neat little reference to what quantum means. Neutron stars, pulsars, and quasars all sound like scary things ending in zars, but they're not really. Neutron stars are basically the cores of dead stars. Once a super giant massive star, not like our own sun is kind of on the smaller end, super massive giant stars die, they leave behind their core, and their core is super dense because it's basically like neutrons and iron, but we don't have to go into neutrons are. They're basically dead corpses. Quasars are this galaxies that are super bright, and they have this giant, center, giant bright center that outshines the rest of their stars in their own galaxy. So we call the center a quasar because it's super, super bright. And well, actually, it's because it's a abbreviation or a little hyphen, shortened form of quasi-stellar object. That's besides the point. They're just super bright, and that's all you need to know. Pulsars are neutron stars that are spinning. Because they're spinning, the universe says, hey, now you get to emit magnetic pulses. And that's where we get the word pulse from. The pulsar actually comes from quasar, but we just added pulse to it because it seems to be pulsing out at regular intervals. Neat little fact, people actually thought when we first detected and measured the pulses from pulsars that they were actually from an alien civilization. I think it was in the 1950s, 60s, because they were so at regular intervals. But that's because the pulsars themselves are spinning really, really fast, like 70,000 times per second. So much faster than this. But point is, pulsars spin and they release magnetic little pulses. Now, nuclear power plants, you may think are really scary, especially with examples like Chernobyl and the Japanese one in 2011 that are really fresh in our minds and what we think of when we think of nuclear power plants. But they're not super dangerous, right? The general idea is using uranium and other radioactive elements to heat up something, to heat up water, which turns into steam. And turns turbines, which basically turns that, rotational energy into regular electricity, kind of like wind turbines. So basically, imagine instead of using coal, we're actually using uranium and other radioactive things to heat up water. And it's a little bit less dangerous, actually. Nuclear power kills less people per energy unit produced than coal and fossil fuels. So consider that. I think we should be switching to nuclear power, but that's besides the point. Dark matter, this is probably my favorite. Dark matter is actually a lot more scary than you may think. Dark does not mean that this matter is going to kill us or that it's evil or, super duper scary. Dark matter just means it doesn't interact with light, and it's really hard to detect it. As a result, it's not immeasurable. Dark matter exists and is supported by by evidence that shows us the universe should be expanding much faster than it currently is. The universe we know is expanding from the Doppler effect, but it should be, if we add up all the mass in the universe, expanding much faster. Now, we know that it's not expanding, this fast. It's actually expanding this slow. So why is it so slow? What is pushing it down or pulling it down to be this slow at expansion? Dark matter. Dark matter is something, again, that interacts with space and time and gravity and pulls the universe together, fighting against the expansion. So the predicted expansion should be up here, but the measured expansion is down here. This is because dark matter keeps things together and prevents, once again, slows the expansion down. And that's what it basically is. It's a little mediator, once again doesn't interact with light, that slows down the universe expanding. So, I hope you have a wonderful week, and I hope you learned something. If you want to learn more about the expansion of the universe and astronomy, check down the astronomy playlist I made below. Bye-bye.